So the next steps of the project for the LTCPs, we still have to look at alternatives. We want to see if there is anything else more we can do in terms of combined sewer overflows. This is the matrix we typically use. These differ from LTCP to LTCP, but typically pretty standard. And it kind of shows a matrix going from, depending which way you're facing, for you, left to right goes increasing complexity, and going down goes increasing cost. So we have some of the GI projects and all, some simple ones, less maintenance. Then you start moving down, diagonal down the chart, you get to retention treatment basins, where you start to talk about big tanks underground, all the way to tunnels, where you're talking about large underground soft soil tunnels that we then have to maintain in terms of cleaning out sediments and dewatering. So that's kind of the list of alternatives that we typically look at. And the ones we retained under this one are highlighted. And again, I apologize, I'm colorblind, I think that's green. And is another requirement on the EPA CSO policy is they give you, we typically look at a large range of CSO reductions, but they say you have to at minimum look at a 25, 50, 75, and 100% CSO reduction. So that we had to look at. The alternatives we thought that were most viable to meet that. There wasn't much land available in the Coney Island area to build any tanks or anything. So the two things we looked at were basically tunnels. One is shaft storage, so that's essentially a large vertical tunnel that I forget, like 30 feet in diameter, I forget the diameter, but just a large deep tunnel that you store the combined sewer overflow in during the wet weather event, and you pump it back to the Coney Island treatment plant. Then we also looked at underground horizontal tunnels, and that's for the larger volumes. That's just, again, we go in with a, they call it a tunnel boring machine, and you just build a large tunnel underground where you store it and you then pump it out also to the treatment plant. So we then also look at the costs associated with these projects and also look at the cost effectiveness in terms of water quality and CSO reductions.